Hello everyone, welcome back to my YouTube class. Today we are going to learn graphical representations of distance and time. Okay. Before we start, let's look graphical representations of motion. What is graph? Graph hi ngeni kan en potang ma. What is graph? Graph is a pictorial representations of variations of two physical quantities. Two physical quantities. Here we have two physical quantities with respect to each other. The two physical quantities are called variables. Here, these variables means they do not have fixed value. Suppose we have graph here. This is horizontal line. This horizontal line is called x-axis. Okay, x-axis, and then there will be a vertical line here, and this line is called y-axis. Okay, then where a point where x-axis and y-axis intersect is called origin. Okay, starting point of your counting. Tatang hian kan chia tran trina hi origin ti an trina ni ma. And then this side lampang hi negative anya, negative value nei thin khania. Lampang hi positive value mo x-axis bika. Since this is this line chon top chin nei lo, you have to put this arrow at the end. Okay, this indicates that this line has no end point, so you can extend as long as you want mo three zong ka chu idu chen chen isiam thei ti nan me this is called graph. In this case there will be two physical quantities pani kan mo that quantities are called variables. In this case one variable will depend on other. If I talk about one variable will depend on other, suppose here we have x value. Let's say here 1 2, this is 2, this is 3 4. Okay, so here also 1 2 3. So if you keep moving toward this x-axis, at the same time etilam y-axis sami poka inge distance ka increase vezelani. It means tan constant in low increase ta se helam panga chuan inge ta hin lo en photila mi mangyan sai fe don. Here we have distance time graph. A graph showing the variation in distance of a moving body from the fixed point with the change in time is called its distance time graph. It can be written as STS. Here S stand for distance and T is time, or DT, you can say DT also, graph in short. Okay? Here D is represented on y-axis and time on x-axis. Okay, distance time graph chuan distance hi S in a mo D in a mo can represent thaya sa time ka chu T mangin can represent don ani ma. At I consider to example explainator pakhat ka pe hilo entaila. In this case, distance time graph for a body moving with uniform speed. Consider an example where a car covers a distance of 20 meters in every 5 seconds. Here we have this is y-axis and this is x-axis. Okay, then this x-axis and y-axis intersect at this point, and this point is called origin. Okay, Then the x-axis will represent time frame, and then this y-axis will represent your distance. Okay, here let's mark here 0 to 1, 2, 3 and 4. Here 0 to 1, this much length. Okay, let's say this is 5 second. 5 second long nita se. Then 1 to 2 also, there will be another 5 second here. Here also 5 second and 5 second. Okay, then your distance y-axis apokhan, your distance here 20 meter, 20 meter, 20 meter and 20 meter. Let's say 1, 2, 3 and 4. The distance between 0 and 1 is 20 meter. 1 and 2 is also 20 meter, and 2 and 3 also 20 meter. Let's say this 1 is x1, y1, y1. This will be y2, and this will be y3. Okay. Yes, this is y1, this is y2, here y3. Okay. Initially you start from your origin and you spend and you consume 5 seconds and move toward, in this case your displacement, let's say here, this is a point where your 5 second and 20 meter intersect this point, and again here, here and here. Okay, yes, this is called uniform speed. And how will you calculate speed in this case? You know, speed is given by distance divided by time. Okay, distance divided by time. Okay, in each point you can calculate your speed. Let's calculate speed here. Suppose we want to know the speed up to this much. Okay, I think he a speed kan jong don ta ni ma uniform speed ani wangin enge khoilai pokhalala a speed kain angwek don thawa. Let's find the speed up to this much. I think he lo jong don ta ila. In this case, see ingle enge in tok ta hian kan anang ni nga minute som 2020 he had tilai mi tur ma he ta mi jok tur ri straight line ania pen hi du angin man thei lawat le mina dang lam deuh laka ta hianin suppose your distance is 0 to 1 is 20, 1 to 2 is another 20, 2 to 3 is another 20. That means 60. Your distance in this case is 60. Okay, 16. Yeah, then your time taken, see 3 3 means 5 3s are 15. Your time taken is 15 here. So 60 divided by 15 will be 4. Okay, 4 kilometer per hour or meter per second. Yeah, this is meter per second. Meter per second. Hey, distance 16 ya, time taken 15 second ani khan, speed ka 4 meter per second. aran chuak don ani hei hi enge graph kan soi kha hemi hi ni tani kelai taka nge x axis le y axis in to na lai hi origin kan ti to ha hemi origin atanga chia tran tur hi nia chuan uniform speed. In case of uniform speed, your graph line you will get straight line ke ta hen straight line in idani. But in case of non-uniform speed, you will get curve line it in curve don ani het in ma hi in chin chi angai curve ani chuan in non-uniform speed ania chuan straight line ani chuan uniform speed ma chuan speed hi nge negative khani thei ma acceleration kha negative ani thei kan tia hi next video kan ran soi fe le tur ni tu na tan chuanin heng ho hi nge graph hi enge ni in a definition hi injek thanga chuan atilai mi distance time graph kan soi fe kha injek bok don ni on okay thleng khani sela in homework tur chu your homework will be you have to write down this definition graph and distance time graph this definition okay eti chau hi aniang voina tan chuan kanin petam lawang tun kara te som dona wangin klem te chau in kanin piang okay your homework will be you have to write down this and this and you have to submit it to me before 7 p.m. Thank you.